sticking out what it calls its rat rock abrasion tool, grinding away the surface of a Martian rock to get at the good stuff underneath, and taking a picture and sends that picture down to scientists on Earth where they can review it, from the safety of their laboratory and say, wow, that looks like, a chunk of iron or a chunk of calcium or whatever the case may be. So they can help us do science. So the last reason why robotics is important, robots are a lot of fun. I mean, people ask me what I do for my job. I tell them robotics. You almost feel guilty because robots are just essentially big, expensive toys. I mean, imagine the coolest toy you have and then multiply it by 10 in kind of cost and complexity. And you get to play with these things all day. I mean, these are photos from that first contest that I mentioned a few slides ago. These kids are having fun. I mean, this is not people doing academic work worried about their grades. These are people who are excited about robotics, working as a team. So thank you for your attention. I hope you have a great time at Science Chicago. And I'm happy to answer any questions that anyone has about robotics. Question? Oh, question here, sorry.
Oh, I asked on behalf of my son.
Mm-hmm.
He's thinking about becoming a biomedical engineer.
Mm-hmm.
His goal is trying to prolong people's lives,
Mm-hmm.
make them live longer.
Right.
Do you have any advice for him? Or?
So the question is, there's a young man who wants to become a biomedical engineer to prolong people's lives. And biomedicine and medical applications, I didn't really show any examples, but this is a really big area for robotics. And people are using robotics to assist, not only in treatment of patients and surgery, you saw rehabilitation, but actually during surgery, but also they're using robotics as prosthetics and as implants. So I just saw a video not too long ago, I think it was on CNN, of a robotic arm. It was a really complicated robotic arm that looked exactly like a human arm with some more gears and motors. But it looked like a human arm, and it was designed for people who had arm amputations, and it would essentially replace their ability to function in everyday life. So it's a great example of the intersection of robotics and medicine and biomedical engineering. My pleasure. Question?
What is the sort of hot topic on the frontier of robotics? And where are we going next?
So what is the hot topic on the frontier of robotics? Actually, robotic medicine is probably the most exciting new area in robotics. A lot of the robots that you've seen have been studied for 20 years, and now they're becoming mature. So these robotic vehicles that can drive around, those are sort of becoming a mature technology. Robots in medicine is sort of the frontier, and people are very excited about it because they knew it can have a big impact on people's lives, but we really don't know how to solve a lot of the problems that come up. Like, how do you design a robot that's actually going to be worn by a person? How do you make it lightweight and comfortable? How do you make sure the person is not going to be frustrated if they can't do something? How do you allow a person to control a robot in an intuitive way? So these are all really, really hard and interesting questions.
He's thinking about the scientists will ever invent a robot that will do homework.
Will scientists ever invent a robot that will do homework? Oh boy, that's a tough one. I think, unfortunately, the answer is probably no. Homework is, they can ask you anything. Robots are very good at doing things in an environment that we say is structured. So they can do the same things over and over, and they'll do it exactly the same every time. They're very good at something like that. When you ask them to do 10 different things, and the task might vary depending on the specific scenario, they become a little bit less good. And when you take away all the structure, you say, well, just do something useful. They don't know what to do, right? And so the less structured you get, the harder it gets to be for robots. Yeah. Here we go. Take two. How long does it take to make a robot? It really depends on how complicated it is. It really does. In my laboratory, we've developed robots in as short as 3 or 4 months, where you've got maybe a few actuators and a few sensors, and you put them together and the robot does something cool. For a very, very complicated robot like some of the ones you've seen, the big dog robot, for example, that probably took a couple of years, or at least several man years. So several guys working on it, or female engineers, several women for a year or something. Usually not more than a year or two, and the reason is that if you spend that long working on a single robot, you know, the technology moves past you, and then the robot you built isn't the state of the art anymore. So you got to move a little bit quickly. Okay, one more question?
I just wanted to ask, you talked about engineering and science and such, but it seems like a lot of robots now, would things like biology, physiology, would also help with understanding how the mechanics of the motion work. Is that also helpful?
Yeah, that's a great point. It does, it really does. This field of biomechanics, understanding the fundamental study of human motion or animal motion. People have started to realize that, you know, one of the greatest engineers is nature. So you can borrow from designs that exist for cats, for humans. You study the way these animals and people move and then use that information in your own design. And it turns out you can design a great robot that way. So what we end up doing is collaborating with people who know about these things, with biomechanics experts, with physicians. And that's another reason why robotics is such a multidisciplinary field. You get all these people with different sets of knowledge and different sets of skills working together, and the result is a robot that can kind of draw on the best from everybody's skills. Question?
What is the recommended knowledge base for programming?
Oh, that's a good question. What's the recommended knowledge base for programming? Usually the people who are really, really excited about programming become computer scientists. They study computer science, you know, but it's not mandatory. I'm a mechanical engineer, and when I became interested in robotics and realized I had to program, first I was terrified because I wasn't a great programmer, but then you realize you can teach yourself enough to get by. And in fact, you know, programming languages these days, to learn the basics, you can teach yourself the basics in a few months. You could study it over a summer and learn the basics of programming. Obviously, there's a lot of really advanced programming, but robotics often, it's not always about being the best programmer, it's about being a clever programmer and being able to accomplish something in a simple way. The best algorithm, the best software is usually the shortest software and the simplest software. Okay, well, thank you very much for your attention.